All right, homework question number 4. We're given an equation. We want to identify the properties of it and make a graph of it. So the properties of a trig function are its amplitude, its period, its midline, and the phase shift. That is the horizontal shift. And some of those we can just look at the graph and guess. So the amplitude is always the multiple of the sine or the cosine. So that's going to be 8. That's the height off the midline. Period we have to calculate. That's always 2 pi divided by the multiple of x. So 2 pi over 5 is the period. That doesn't really clean up. Midline is the horizontal line that goes through the middle of the wave, and that's always this plus or minus out here. So the midline would be y equals 7, and that's an equation. And the phase shift is how far it was shifted left or right from where it normally starts. So this one has a phase shift of just 6. Things to consider when you identify these from an equation: the interior of the function, called its argument, has to be factored to figure that out. Otherwise, you get the wrong phase shift. So it's got to be factored in there. And then otherwise, because things kind of happen backwards in here, it's always the opposite of the number I see here. So this is x minus 6, so I say the phase shift is 6, right? So remember opposite sign for that number. Otherwise, it's pretty straightforward. Now, based on that information, I can make a graph of this because I know what the period is, I know what the midline is, and I know what the phase shift is. And I know it's a sine, and I know that normally the sine cuts through the origin and peaks, and on the other side of the origin it has its minimum, right? So this is the normal sine function between pi and negative pi, max of 1, min of negative 1. So that's a graph you should have commit to memory, and then it just repeats that pattern over and over and over and over again. So let's try to graph this one here based on this information. And let's see, midline's way up there, so I'll put the x-axis down here and then mark some stuff off. Let's go, I guess, 1, 2, 3, 4, 5, 6, 7 is going to be my midline, and then the amplitude is 8, so then we have to keep counting. From 7, we have 1, 2, 3, 4, 5, 6, 7, 8. So that would be 15 up here. This is my 7. Going 8 the other way is going to take me down to negative 1 there. So I know that this graph goes through the middle here. And actually, let me pick a different color for that. Somewhere like that, close enough. So that's the midline of the graph. And then some other things to consider. We have the phase shift of 6 to deal with. So let's count that off. So normally the sine slices through right here, but we got to shift that over. So 1, 2, 3, 4, 5, 6 would be right here. Oops. Come on, zoom out of the way. There you go. So that's 6. So I'm going to have a point right here at 6, 7 that it's going to slice through there. The period is 2 pi over 5. So the period is the length it takes to complete one wave. So let's see, what is about 2 pi over 5? Calculator. 2 pi over 5 is about 1.2. Oh, wow. So this thing oscillates quite a bit. That's an idea called frequency I'll talk about in a minute. So it completes a period every, oh wait, no. Yeah, no, that's the period, right? Divide by 5. All right, so about 1.3-ish is the period. So my scale is going to make this very hard to draw. And often first try on something like this is a little messy. So it's going to complete a wave. So that's 6 right here. 7 would be about there. 8 would be over here, right? So 6, 7's here, 8's here. In the period of about 1.3, which would be, let's use a different color, how about blue? the distance from here to about there, it's going to complete one wave. And in between there, so right, it's going to hit again right there. It's going to rise up to its maximum. It's going to hit again in the middle. So the max is going to be way up here. The min is going to be in between these 2 points, so way down here-ish at -1. And this is going to be super hard to draw. That point's a little bit off. So it goes up through there, comes down through there, it peaks up there. So I get this skinny little wave. Ah, that went like hell. Try that again, Gary. It's going to go all the way up, bounce off, come down, head all the way down, bounce off, and then come back over there. Ah, my pen skills are not good today. And it's going to keep waving like that over and over again. All right, that was a crap picture. I can redraw that, but I think I'm just going to whip out my calculator to double check. So let's bring up a new screen and make sure it behaves the way I think. So y equals 8 times the sine of, there we go. And we had 5 parentheses x minus 6. Notice how fast it's oscillating there, right? And then we had a +7 outside. And so we were focusing around 6 here when I started it. So you can just, and let's rescale. And GeoGebra has a cool rescaling tool. Let's see, where is it? If you go to the move tool, and then you grab an axis, you can resize just that axis without resizing the other one. Right, so on my paper, it was going to look kind of like this, and I had this one even narrower on my paper. Right, so this one oscillates pretty rapidly compared to the regular sine. So let's compare the regular sine to this. Right, so the regular sine in comparison, right, oscillates a lot more slowly. And so when I talk about oscillations, that's the number of waves in a given unit. And that's an idea called frequency. So I might as well define frequency and then we'll move on. Excuse that horrible sketch there. So frequency of a wave is equal to 1 over the period, and it is oscillations per unit time. So per second, per minute, however we're measuring time. So with this one right here, if I look at 1 over the period, so 1 over 2 pi over 5, which is 5 over 2 pi, calculate that, and we'll see what that means on the graph. So 5 divided by 2 pi, I get 0.8-ish. So every unit, this does like 80% of a complete wave. And so just to see that happen here, let us graph the line x equals 1. So between the y-axis and that line, it doesn't quite complete an oscillation. Notice we are here just above the midline at 8, so that points on the axis there, and we don't quite get to that 8 again in 1 second, say, right? And so that's what this frequency is telling me. I get 80% of a wave in 1 second if I were measuring time in seconds. Compare that to the regular sine. So regular sine has a period of 2 pi, so its frequency would be 1 over 2 pi. And so that means it only gets about 16% of a wave in 1 second. And so we can see that here with the blue curve, let's get the other one out of the way, we only get a fraction, a small fraction of that complete cycle, which ends over here in 1 second. All right, so its frequency is about 16% of a wave per second. And we can make a frequency, just like we can change the period, we can make the frequency anything we want by just thinking about the reciprocal of the period. All right, let's try another problem.